Blue carbon is not just a huge buzzword in the conservation space. It's a field within conservation that could help the oceans recoup from climate change impacts. There are many startup companies that are popping up in this space to get in on what could be a lucrative business model for the near future and a way to save the planet. However, there are still many questions that remain unanswered for the space that could have unintended negative impacts on the ocean and the planet. For example, a recent study revealed that coastal ecosystems may release methane, a more severe greenhouse gas than carbon dioxide, after absorbing carbon dioxide. We're going to discuss these effects and why is it so important to know this type of information on this episode of the How to Protect the Ocean podcast. Let's start the show. Hey everybody, welcome back to another exciting episode of How to Protect the Ocean podcast. I am your host, Andrew Lewin, and this is the podcast where you find out what's happening with the ocean, how you can speak up for the ocean, and what you can do to live for a better ocean by taking action. And today's episode is a really interesting one, I find. That's why I like to do these episodes, because I do what is interesting for me. Anyway, we're going to be talking about blue carbon, but in fact, we're going to be talking about some of the effects that we rely on some of the effects that could happen when we rely on CO2 being absorbed by plants, especially coastal habitats. A new study that was covered and written about in Manga Bay News. We love Manga Bay News here at the How to Protect the Ocean podcast. If you go to mangabay.com, you can get all your ocean news, trees, forest news, a lot of environmental news that you've never even heard of these stories before. It's fantastic. They're not a sponsor. I just love it. That's my go-to when I look for ocean news to cover on this podcast. We're going to be covering a bunch of them coming up, and this one is included. So essentially, coastal ecosystems, it says here in the description, I'm going to kind of read it over here. Coastal ecosystems take in huge amounts of carbon dioxide from the atmosphere, but researchers are still deciphering how much methane, a far more potent greenhouse gas, they will put back in the system. Researchers studying seaweed and mixed vegetation habitats in the Baltic Sea found they emit methane equivalent to 28% to 35% respectively of CO2 that they absorb. And the findings highlight that more work needs to be done to understand methane emissions in different coastal areas to get better accounting in the carbon balance sheet. This study, this article that we're seeing here in the Manga Bay News that covers this study, is really about the carbon cycle. It's about looking at the carbon cycle and what it will do for the atmosphere, what it's going to do to climate change. That's what it's really about, right? A lot of times when we look at blue carbon, we look at, mangroves, seagrass, right? We have a lot of other sort of coastal habitats like mudflats, salt marshes, things like that. They actually absorb quite a bit of carbon dioxide. So great, carbon dioxide is a greenhouse gas that we need to reduce. So the ocean absorbs a lot of it. The ocean absorbs it through phytoplankton, through seagrasses, through mangroves, much, much more than trees do in a forest on land. So this is a good thing, right? Well, this study is kind of saying we need to throw caution in the wind in certain places because depending on what's in the ecosystem, how it's breaking it down, how these organisms that are found in the ecosystem are breaking down the CO2, it could actually increase methane back into the atmosphere. And you don't want that because methane is worse than carbon dioxide in the atmosphere. Now, how much methane is actually going back in compared to what's coming out? That's a big question. How much CO2 is coming out, right? And we're still going to have to do way, way more research to figure this out. But blue carbon is just blowing up everywhere. In fact, I actually helped produce and put together and edit a podcast called Sea Plan. It's a great podcast that talks about carbon removal systems, especially within the ocean. It's very, very policy oriented, a little bit scientific, but talking about the pros and cons of looking at carbon capture. Carbon credits. It's looking after carbon credits and all of these different types of carbon systems that people are coming up with and startups are kind of coming up with all over the place to figure out how not only could they make money, but also decrease the impact we have on the oceans. Carbon credits and just sort of any kind of carbon pricing is going to be huge in the future. Whether you like it or not, it's coming into the forefront. There are a lot of companies that are vying for this. It actually reminds me, I know this sounds weird, it reminds me when Canada was about to start to legalize marijuana. All these companies companies kind of came in trying to, bid for the highest, being the producers, being the suppliers, getting all the stores, all that kind of stuff. And then they had to work within sort of government regulations to find out, will this work? How will the pricing be? How will it be sold? Will it be privatized? Will it be through government vendors and all that kind of stuff? And there was a lot of stuff going on. A lot of people took a lot of risks. Some people made a lot of money. Other people, not so much, and went maybe bust. But it reminds me of this. This is sort of like everything's chaotic. Everything is hectic. People are trying different things. There's a lot of seaweed. There's a lot of seagrass. There's a lot of mangroves. There's a lot of potential in restoring these types of habitats where you can actually benefit not only in a reduction of climate change in terms of reduction of CO2, but you can benefit in building up these coastal habitats that are great for, nursery areas for fish and invertebrates that are trying to grow to a certain size before they go out into the ocean. You have a lot of hiding spots for predator-prey relationships. It solidifies the coastal zone. It decreases energy of waves that come in. So any kind of storm surges or any kind of God forbid, tsunamis that come in, you actually get a reduction in wave energy. So these systems, being able to revitalize them, restore them to that point, to pay that money to do that before was very difficult. It was hard to do because it's so expensive to do anything in the ocean, especially when you're trying to revamp or restore a habitat. Now there's a little bit more money involved, right? Because the more habitat you have, the more mangroves you have, the more seagrass you have, the more salt marshes you have, the more you're absorbing carbon dioxide. And that's the key right here. So that's what everybody's like, hey, there's multiple benefits to restoring these habitats, to protecting these habitats that are already there, and to discovering new habitats and what to do with them and getting them protected and monetizing them, to be honest, for a lot of these countries. A lot of countries that have, seagrasses, mangroves, and so forth are sometimes small island states that need a little help, that are seeing the effects of carbon dioxide in the atmosphere and methane and greenhouse gases and climate change, and they're feeling the effects of the higher sea level rise. They're getting the effects of the more intense storms and more of those storms. They're seeing those effects. They're seeing the effects of a lot of different things, and it's about time that they can monetize these areas. In fact, just recently, a friend of mine, Dr. Austin Gallagher, who is the CEO and founder of Beneath the Waves, him and his crew, they actually were tagging tiger sharks, and one of those tiger sharks, they put a video on them, a video camera on them, and they went into one of the largest seagrass areas potentially in the world. I forget the actual what the accolade is, but it's massive. It is massive, and the Bahamian government is going to use that to monetize for carbon credits. So we're seeing a lot of advantages in this for a lot of countries that need the help, that need the money, and a lot of countries that need to offset their carbon with credits. That'll happen in the future. So I think it's a really interesting space. It's why I teamed up with Will Burns to do this type of work. Hopefully we'll have him on the podcast soon to dive more into the blue carbon space and carbon removal space and what it looks like when we're talking about reporting and evaluating what's the right number. It's a really fascinating space. But in this situation, we're talking about methane. So all these benefits are happening, and we're saying, we're gonna increase carbon dioxide. But just like I mentioned, a lot of the blue carbon space comes down to how do we evaluate how much carbon dioxide is being taken out of the atmosphere, how much greenhouse gases is being reduced by having those habitats take them out, and then how much is getting put back in. Because there was always a number. There was always a small number of the output being methane. And essentially what happens when carbon dioxide comes in or things get decomposed at the bottom of the ocean, oxygen and carbon dioxide can be taken in to create through a chemical process, methane as an output. And so when you have methane getting out from the ocean into the atmosphere, you get even worse greenhouse gases. And depending on that amount, that can be a huge problem for the planet, especially if we're going to start scaling this industry, this blue carbon industry. They're talking about sinking different types of vegetation, some algae. They're talking about sinking, like cultivating and sinking seagrasses and mangroves and so forth. But we don't know what the effects of that sinking is going to have, right? In this study in particular, they looked at 3 different types of habitats. They looked at, this is all in the Baltic Sea, and they looked at bladderwrack stands, which is like a seagrass, I believe. They looked at mixed vegetation, and they looked at bare sediments. 3 different things. They expected the mixed vegetation and the bare sediments to have a methane output. They didn't expect the bladderwrack stands to have an output. And the reason why is because the other 2 have sort of a sandy bottom. And in that sandy bottom, you get these organisms called methanogens. And methanogens are the ones that break down all the detritus. So any mixed vegetation that falls to the ground gets decomposed, and that methane gets released. The same thing will happen in bare sediments. Bare sediments will have these little microbes, methanogens that come in and break down anything that falls on them, and then they'll release methane. And then now with the bladderwrack, they were pretty surprised because bladderwrack actually is on a lot of rocks. But what they noticed that there's these little pockets between the rocks that had sediment in it. And in that sediment, they had the methanogens. And those methanogens were producing methane. And so they were surprised, although probably not the same level, they were surprised that the methanogens are coming in here. And this is not to say that blue carbon is not going to work. This is to say we need to be careful and we need to evaluate everything. I keep hitting the microphone. We need to evaluate everything that we see and we start to look at for this blue carbon space. And we need to make sure that we don't rush into things, right, too quickly and make things worse just to find out, hey, we have this space, it works. With that said, there are a lot of challenges when you start to dive into a new space. It doesn't mean that we can't overcome those challenges. It doesn't mean that we can't take CO2 out and put a little bit of methane in. Maybe if we take enough CO2 out and only put a little bit of methane in, maybe that will offset what we need. The fact of the matter is, and this article kind of goes on in this kind of direction, is we need help. We need to do everything we can. We talked a couple of weeks ago in another podcast with Dr. Andrew Thaler about deep sea mining. And, he was saying the same thing. The mining companies truly believe that we need to get a lot of these minerals out to pump into the EV space to make the batteries because we need more EVs on the road. It's not just to make money, it's also to save the planet. And he's worked with a lot of the people in there, and he strongly feels that they believe in that. He says there's probably some players that don't really care, they just want to make money in a new space, but a lot of them, a majority of them want to help the planet. And right now, mining the deep sea is a better situation, and we can reduce climate change than not doing anything at all or doing something different. So although we always caution, be careful what you do in these types of situations when we're going into habitats where we don't really know a lot about. You'd be surprised at how many things we don't know about coastal habitats, especially the carbon cycle. This is where, biogeochemists will come in. This is where a lot of chemistry, a lot of physics will come into play, and we're going to have to study the carbon cycle a lot more than just saying, hey, there's a lot of seagrasses in one area. There's a lot of mangroves in one area. There's a lot of salt marshes in one area. We can use this for carbon credits, and we can put this into play and start to manipulate the area so that we can sink some of the detritus and really start to absorb carbon and use it as a sink. That's a huge term within biology, within marine biology. Sinks and sources. You look at sources of carbon dioxide, sinks that would actually absorb carbon dioxide. You can look at sinks and sources from a biological standpoint too, where you have a source of larvae that comes in and a sink that actually takes in the larvae and provides a habitat for it. So it can work in a lot of different ways. But in this case, we're looking at it from a carbon cycle perspective. And I just think it's interesting. I think, it's something that we definitely need to look at more. We definitely need to put more information, more resources, more funding into it. And luckily, there's a space that wants to do it. So hopefully there's enough investors in there. Hopefully there's enough venture capitalists in there that will do that. And we can figure out with the combination of scientists and conservationists if this is truly the right thing to do and whether we should look at what happens in shallow coastal areas compared to deep sea areas. So there's a lot of questions in this, and I would love to hear what you think about this whole situation. Leave a comment in the description below if you're looking at this on YouTube, or you can contact me by DMing me on Instagram at How to Protect the Ocean, or you can even go to our website, speakupforblue.com/contact, and you can just fill out the form with your question or comment, and you can email me. It goes right to my email. I'll answer back in a few days. So that's it for today's episode. Really want to hear what you think. Thank you so much for joining us here on the How to Protect the Ocean podcast. I am your host, Andrew, and have a great day. We'll talk to you next time, and happy conservation.